Hello everyone. Today we will cross two one-size-fits-all old Bushni worthless with a light bulb 220. This is an economy LED light bulb, designed for a network of 220 volts. Naturally, for this we will need two Bushni one-size-fits-all, an old phone that is not a pity. From here we will take the power button and also remove the micro USB connector so that we can charge our homemade. To begin with, we need to disassemble the one-size-fits-all themselves. We pick out the plastic plug from below. After we pulled out the plastic plug, the battery follows it and then the wires to the evaporator. We do the same procedure with the second one shot. We will take two batteries from these one-size-fits-all units. We also unfasten the upper diffuser from the lamp. Inside we see a whole scattering of SMD components and LEDs. All this is filled with sealant, which needs to be picked out in order to get the board itself. The board is also a heat sink, made on an aluminum plate. We will also solder our diodes on it. Carefully remove the board itself. There is nothing on the reverse side except the electrolytic capacitor. And we still have a beautiful body from a light bulb with a base in which we will place our homemade. We disassemble the electronic sishku to the end. We will need a housing from one of the sheds. And now let's start removing all unnecessary components from the board. We need to remove all the SMD components, since we don't need them in this DIY and they will only get in the way. We heat up our board with a hairdryer. After warming up, all components are easily removed from the board using tweezers. And we are left with a clean bare board with LEDs. All our diodes are connected in series, so we need to scratch the copper tracks with a scalpel or other sharp object to separate our diodes. We will connect them not in series, but in parallel. Since our battery voltage is low and only parallel connection of diodes is suitable for us. Copper is a fairly soft metal, easily cut through with a knife or scalpel in my case. We walk around the whole circle, break the chain. Initially, I planned to use diodes that are installed here from the factory, but after measuring it turned out that these are high voltage diodes and each diode operates at a voltage of 40 volts. Naturally, we have nowhere to take such a voltage and we also removed the diodes. Instead, we will solder these diodes from the LED strip. The tape is designed for 12 volts, but due to a step-down resistor, the voltage is reduced and each diode is powered by a voltage of 3 and 4 volts. Carefully solder off all our diodes from the LED strip. We'll need 7 pieces. We prepare the landing place, apply a little flux and thoroughly tinned with rose alloy. The rose alloy is low temperature, melts at lower temperatures than ordinary solder. This is necessary in order not to overheat our diodes and they lay down properly on the seats. Diodes are quite delicate, they are afraid of temperature, so we use the rose alloy. After preparation, we heat the plate and carefully put the diode in its place. The main thing is not to get carried away with the temperature of the hair dryer, so as not to float, not to burn our LEDs. As a result, this is the result. I have 6 diodes of white color and I took 1 diode of blue color, since there was no white. We check each diode after installation, so that everything glows, everything works. At this stage, if something is not so easy, it's all replaced with a new diode. And now we are preparing nickels for which we will be soldered with wires. Next to each diode, we clean the mask, carefully scrape the top layer of this mask with a scalpel until a copper track appears. It is on this nickel-copper track, we will solder our wires and connect the diodes in parallel. We apply the flux to the prepared sites and tin each nickel, preparing it for soldering wires. For soldering, we will use a thin tinned wire and we will connect everything to one point. For this point, I chose a seat for the chip. There is a lot of space there and all the wires will be soldered to this particular seat. This will be the central point of the minus wire. Here we will have a minus or mass hanging in a different way. Our diodes consume very little current, so thick wires are absolutely not needed here. These hairs are quite enough. They will easily withstand the load that each diode will consume. After we have soldered all the wires to the central point, we check whether all the diodes work with us, whether the contact is more reliable, and after that we prepare the nickels on the other side of the diode, where we will have a plus. In the same way, with a scalpel or other sharp object, we clean the mask before the appearance of a copper track and prepare the nickels for the plus wire. Also, we apply a little flux to each nickel and tin it with a soldering iron. Next, we take the same thin tinned wire. We have a wire without insulation, without varnish, just hanging a little in the air and connecting each diode, plus output to each other to make one central plus. We solder it for each kitak. After all the manipulations, we have a central minus and a central plus. We also check with the tester whether everything is working, whether each LED is lit. And after checking, it is already possible to start soldering two wires already in insulation, where we will have a blue minus and a white plus, respectively. Next, we proceed to the preparation. We carefully remove the button from the old phone, heat it from the reverse side and perform the same manipulation with the micro USB connector that we need to charge the device. The button is carefully soldered, ready. We will solder two wires at once. The wires here need to be used naturally in isolation. The wires are as thin as possible, since there will be absolutely no load here. Now we prepare the lamp base, drill a hole for the button. Since the button does not fit into the round hole, we use a Dremel, and now we will slightly expand the hole, the seat for our button. The lamp body is metal inside, so we use a Dremel. If there were plastic, it would be possible to burn with a soldering iron. We try on our button, see that it fits well into our hole, expand it a little more. And now you can fix the button with hot glue. We heat up a little hot glue, coat the button and carefully insert it from the inside. All our button is sitting in its place, everything turned out well. Now we need to get rid of the lower part of the base, make a hole, heat the plastic. We need a hole so that we can skip the wires and gently tear off the soft plastic. We pass one wire through the lamp, and the second one is immediately soldered to our LED panel. We will have a button in the gap of the plus to go, and we will pass the minus down the lamp and attach it directly to the battery. We dissolve the wire, the minus one went down through the lamp, and we shorten the plus one and solder it with a button. The connection point must be isolated so that nothing closes anywhere, since we have a metal lamp body inside, and we snap our LED matrix into the panel, into the lamp body, where it holds perfectly, does not fall out. And then we need a case from a disposable Sishka. Before we glue the case, we only need a limiting resistor. I dug it out from an old non-working charging. This resistor is at the input, its resistance is 10 ohms, you can use another, 5 ohms, 15 ohms, there is no difference. The main thing is that it should be small, otherwise the matrix will not glow at full brightness. Resistance is needed, firstly, so that our diodes do not burn out. Our diodes are powered by a voltage of 3/4, and our batteries give out from 3 and 7 to 4 and 2 volts. Therefore, this resistor will limit the voltage and, accordingly, reduce the load on the button and diodes. We also isolate the resistor so that nothing is closed anywhere, and we pass ready-made wires into the case from the one piece, try it on, and now we will glue it. We will glue on a 2-component epoxy adhesive. Squeeze out the 2 components in equal quantities and mix well. The main thing is to mix everything thoroughly well, otherwise the glue may not harden in places. This epoxy adhesive seizes literally in 3 to 4 minutes, completely becomes solid. Therefore, we quickly knead and immediately smear the inside of the case from the single cut. We coat the entire perimeter with our epoxy glue. We put it straight, fix it so that nothing falls. And we wait, literally 5 to 10 minutes, until all the glue is completely grasped and becomes solid. The case has seized, stuck together, you can do the batteries. We connect the batteries in parallel to increase the capacity, that is, 2 batteries connected in parallel will have the same voltage from 3 and 7 to 4 and 2 volts, but the capacity will be twice as large. We solder two batteries together with minus contacts, that is, we solder two minus batteries together. Also now we need to connect the two advantages of the resulting battery. Immediately solder the plus to the wire that goes to our button. We are also preparing one wire that will go down the housing, and we will solder it to the micro USB socket so that we can charge our batteries. We connect the second plus from the battery. The upper part of the plus, where we did everything, soldered, immediately isolated with Kapton tape. You can use ordinary tape or duct tape. The main thing is to insulate so that we don't have anything closed anywhere, since the one-piece housing is aluminum and easily conducts electricity. Now we solder the negative wire from the matrix to the total minus of two batteries. We also need a tap from these negative batteries to the bottom, to the charger. We have all soldered. Now we carefully fill the batteries with wires into the one-piece housing, but we do not fully insert them. We check the work. We see that everything is working, and it's time to get busy with the charger socket. In the plastic plug of the one-size-fits-all, we grind out, cut out the hole. We also use Dremel. Trying on our connector. We file in the right places so that everything gets up, and after the hole is prepared, it's time to connect the connector to the cable and measure on which contact plus on which minus. On this connector, we have a plus on the right, a minus on the left, two extreme contacts. We remember all this. Insert the connector into the housing and first fix it with hot glue so that it is more or less centered and in the right position. We correct the connector. The hot glue holds it. Now you need to shove a little paper, napkins, and we will already impregnate it with super glue. Since the hot glue is not durable, it will not withstand the connector, but super glue with paper will fix it perfectly in our connector. We also pour a little ordinary baking soda. And we will also spill this soda with our super glue. As a result, the glue hardens in a couple of seconds and it turns out something like a durable plastic. All this is securely fixed and our connector will hold well. We remove excess glue from the contacts. With the extreme contact, we will solder the charging wires, strictly observing the polarity of plus and minus, which we learned in advance. Immediately solder the wire to the extreme contact of the connector. We are already soldering the second negative wire directly from the housing. And now that we have everything soldered, we also use Kapton tape, or ordinary tape. We isolate it so that our connector does not close to the battery plus. And carefully push all this into the case. There is enough space to shove 2 batteries and close it all with a plug. We close it tightly with a plug. And in general, everything is ready. It turned out quite neatly. We put on the cap, let's see how it will all glow with the cap. A wonderful lantern turned out, it shines very brightly. Also, do not forget to check our charging connector. We connect the cable and the charge goes. We don't have any indication, because we didn't do it, but we can easily check the performance using a USB tester. We take our USB tester and connect our flashlight to the power source through a short wire. As we can see, our consumption is 0.3 amperes, the charge is on, everything is charging. Here is such a successful experiment we have turned out. The consumption of diodes is scanty and approximately according to modest calculations in my head, this flashlight should glow on a single charge for several hours. You can use it with or without a hood. Also, if desired, you can install a lens instead of a hood and get directional light. Such a wonderful homemade product turned out to be 2 old electronic SciJack and an ordinary lamp 220. Thank you all so much for watching, bye.